Hi guys, so welcome to example 6 for projectile motion. Okay, let's jump right to it because this is a long one. A projectile is fired with an initial speed of 62.5 meters per second at an angle of 35.4 degrees above the horizontal on a long flat firing range. Determine A, the maximum height reached by the projectile, B, the total time in the air, C, the total horizontal distance covered, in other words, the range, and D, the velocity of the projectile 1.05 seconds after firing. Okay, so starting off with part A, so let's go into that first. The maximum height achieved by the projectile. Now, in order to determine this, you have to understand what happens at the maximum height, what physical properties change at that point. Okay, so let's draw a picture. So here's our initial speed. We've got an initial speed of V naught equals 62.5 meters per second. That has both a horizontal and a vertical component. Okay, and that's done at an angle of 35.4 degrees. Now, this is simply showing us what's happening with the vector, the initial speed, but in general, the motion of this projectile can be shown like this. It's fired, it goes up, loses the battle with gravity, falls back down. And it says it's a flat firing range, so it should start and stop at the same point. Okay. The maximum height achieved by the projectile, so that means we're looking for this height here. Now, because we're looking for that height, we have to set our zero, our origin. So why don't we just let this line right here be y naught, and that's going to be considered a height of 0 meters. Okay. Let's establish a positive direction for this problem, or two sets, since it's two-dimensional. Let's let upwards and to the right be positive. Okay, now back to what I was saying before about the maximum height. The idea is this. At this point, at the very top, the vertical component of the projectile's velocity is 0. So at that point right there, Vy equals 0. Now, as soon as you make that connection, the rest of this part A is going to be very straightforward. So once you make that, okay, Vy is 0, you've set this down here, this height to be y naught is 0. You're looking for the height here, y. And there's another thing you know in the y direction. It's that acceleration in the y direction is 9.8 meters per second squared. Now, because we defined up to be positive, we need to put a minus there. And there we go. Okay, we've got a lot of variables in the y direction, so we're just going to go ahead and solve for this in the y. Okay, so let's see. We've got a final y speed, an acceleration, initial y position, final y position. There's actually one more y quantity that we can determine, and that comes from the initial information given in the problem. We know v naught and we know the angle, so we can just very easily determine v naught y. So let's do that on the side. Okay, so V naught y, based on your understanding of a right angle triangle, this V naught y is opposite to the angle, so it's going to be the hypotenuse. Opposite is sine. Okay, so it's going to be 62.5 times the sine of 35.4 degrees. Okay, when you calculate that out, you're going to get V naught y is equal to 36.205 meters per second. Okay, so we got quite a few pieces of information in the y direction. So we've got our acceleration, final y speed, initial y position, final y position is what we're looking for. Okay, we got all the ingredients necessary. Now for the equation, okay, the equation that relates all of these variables together is the following. Okay, so 2 times acceleration times the change in displacement, the acceleration is in the y direction, is equal to the final y velocity squared minus the initial v naught y velocity squared. Okay, now the quantity we're looking for, the y, is embedded into this delta y. So let's get the delta y separated into its two components. 2ay bracket y minus y naught, right, because the delta means change, vy squared minus v naught y squared. Okay, so we already established that the vy is 0, so we're just going to go ahead and remove that. Okay, there's something else we established to be 0 here, and that's the initial y height, y naught. So that's also becoming 0. Okay, so this is simplified quite a bit. Now you've got 2a y equals minus v naught y squared. So 2ay times y equals minus v naught y squared. Let's isolate this for y since that's what we're looking for. I'm going to shift this up a bit. Okay. So to get y by itself, you have to divide both sides by 2ay. Okay, so minus v naught y squared over 2ay. We calculated v naught y squared to be 36.205. Don't forget that negative in front. Negative 36.205 meters per second, and that gets squared. Divide that by 2a. Remember, we defined up to be positive, so a is negative 9.80 meters per second squared. That's pretty handy because the minuses are going to cancel, leaving you with y equals 66.9 meters. Okay, so there is your maximum height, and the problem does want us to give it to 3 sig figs since both 62.5 meters per second and 35.4 degrees have 3 sig figs. Okay, so there is your answer for part A. Okay, so we're 25% of the way through the problem. Part B, the total time in the air. So I'm just going to make a separation here. Part B, the total time in the air. Now, there's 2 ways to go about this. If you want to look back at the original diagram we have, I mean, essentially the projectile is carving out an arch. Okay, so the first way you can determine the total time is find the time it takes for the projectile to get from the starting point to the maximum height, and then double it, right? Because assuming this is very symmetrical, okay, in a perfect world, then you can simply double it. The other way to determine this is, well, you see how it starts at y naught equals 0? Well, it also lands at y equals 0 because it's a flat horizontal firing range. So therefore, the change in the vertical displacement is 0. Okay, so if you want to keep working with the vertical direction, you can actually determine it like that as well. Okay, so we can actually say that because it starts and stops in the same part, delta y is equal to 0. Okay, delta y is 0. We now know the maximum height reached. We don't need to use that for this part. But let's go ahead and use this formula. Delta y is equal to v naught y t plus 1/2 acceleration y t squared. We know acceleration in the y direction. We know v naught y. Delta y is 0. We just have to solve for t. It's as simple as that. Okay, so let's start plugging in some values here. So 0 for delta y. V naught y we calculated, remember, it was this number in blue, 36.205. And that's going to be multiplied by t plus 1/2 times acceleration in the y, the negative 9.80. We're going to close that bracket. T squared. Okay, now let's do this. I'm going to bring the t squared to the front. It's always proper mathematic etiquette to bring the higher powered term forward. So 9.8 negative times 1/2 is minus 4.9 t squared plus 36.205 t. Now we don't actually need the quadratic formula for this, which is really nice. We can simply add negative 4.9 t squared to both sides, giving us the following statement. 4.9 t squared equals 36.205 t. Okay, this is nice because we can now cancel out 1 t on both sides, leaving us with 4.9 t equals 36.205. To get t by itself, simply divide both sides by 4.9, and you're going to get, finally, t is equal to 7.39 seconds. And now, there is actually one more answer that works here, right? If you multiply, if t is at 7.39, that multiplied by 4.9 will give you 36.205. So there you go. There's one other answer that actually works for this. If you were to plug in 0 here for t, it would make both sides of the equal sign match. So technically, t equals 0 is a solution, but this is when the ball was launched. Okay, so this is not what we're looking for. right? Because at that point, the delta y was also 0. But we want the delta y 0 after a certain amount of time, so therefore 7.39 seconds is your final answer. Okay, so part B is done. Okay, so let's move on to part C. Part C is asking us for the total horizontal distance covered, in other words, the range. Okay, so let's do that on a completely separate page here. Okay, so part C, total horizontal distance covered. Now, the nice thing about projectile motion problems is in the x direction, as you've seen now many times, the acceleration is 0, which makes the calculation super straightforward. Okay, so the range is going to be simply delta x, and it's just the speed in the x direction times time, right? Normally you'd have the plus 1/2 acceleration times squared here, but we don't have acceleration, right? It's 0, so we simplify down to this basic formula. So we need to find Vx. We're going to do that based on the original information in the question. Okay, so originally, remember we had our V0, it was 62.5 meters per second. And then we divided this up into vertical and horizontal components. We determined the V0y, and again, this is at an angle of 35.4 degrees. You see how I've labeled this V0x? Technically, you don't even have to write it as that. You can just write it as Vx. Since V0x and Vx are the same, there's no acceleration. Okay, so the way in which you figure this out, Vx is adjacent to the angle we're given. So simply what you have to do is do Vx equals the hypotenuse, which is 62.5 times the cosine of the angle, which is 35.4 degrees. And when you do that, you're going to get Vx equals 50.945 meters per second. Okay, so there we go. We can use that, plug it in for Vx over here. And we just figured out the time that it's in the air, so we're going to use that time from part B. Okay, so equals 50.945 meters per second. And we just found the time to be 7.39 seconds. That cancels out the seconds. And when you multiply those two numbers together, you are going to get 376 meters. Okay, so there you go. There is your answer for part C. That is the range. And yes, it is as simple as that. And finally, in the last 25% of the problem, the velocity of the projectile 1.05 seconds after firing. Okay, so the velocity of a projectile is going to have components. Okay, it's going to have a vertical component and a horizontal component. The nice thing is we already know the horizontal component. It hasn't changed. It's going to be your Vx is 50.945 meters per second. What we have to figure out is the vertical component at that point in time, at 1.05 seconds. Now, we already know that the vertical component initially is 36.205 meters per second. So let's just say that we need to find Vy when t is equal to 1.05 seconds. Now take a look at this. We also know in the y direction acceleration, and that's negative 9.8 meters per second squared. So at this point, you've got 1, 2, 3, 4 variables to work with, one that you don't know. Okay? And the formula you're going to use is one of the most basic definitions in physics, and that is that acceleration is defined as the change in velocity over change in time. So AY is equal to delta Vy over t. Okay, so our delta Vy is going to be our final Vy minus initial V0y divided by t. We're looking for Vy, so let's rearrange this. The first thing you need to do is multiply both sides by t, and then you're going to add V0y to both sides. Okay, so when you do that, let me do this on another sheet here. Okay, so first you bring the t over, so it's AYT equals Vy minus V0y. Then add the V0y to both sides, so you're going to get V0y plus AYT equals Vy. And that's what we're looking for. Okay, we know everything else. I'm just going to do a quick switch. Okay, so you get your unknown on the left. It's just standard notation. Okay, so Vy equals, okay, our V naught y is, where was it again? 36.205 meters per second plus Ay is negative 9.80 meters per second squared. And we're looking to find the Vy when the time is 1.05 seconds. Okay. So multiply these two out, you're going to get a negative number. Add that to the 36.205, and you should get a final result of Vy equals 25.915 meters per second. Okay, now we're not quite done. So we've got our Vy at t equals 1.05 seconds. We know that at any time, including 1.05 seconds, Vx is going to be equal to 50.945 meters per second. So all we have to do now is construct our triangle. So you've got your Vx, your 50.945 meters per second. You've got your Vy, 25.915 meters per second. And the two of those meet at a 90-degree angle, since you got an x and a y. And their sum is going to give you the final velocity of the projectile at that time. Okay, so let's find that. We're also going to need the angle, but let's do the velocity first. So you probably saw this in previous videos. We have a right angle triangle. We know two sides, and they're both not the hypotenuse. So the way in which you determine this is v squared. It's the Pythagorean theorem. Okay, v squared is equal to vx squared plus vy squared. So v is equal to the square root of vx squared plus vy squared. Plug it in. Vx is your 50.945 meters per second squared plus your vy squared. 25.915 meters per second squared. Square, square, add them together, take the square root of the sum, and you're going to end up with your speed as 57.2 meters per second. Okay, now we were asked to find velocity, so we need to still find the direction. And we're going to do that also from this diagram. Okay, just like again in previous videos you would have seen, we are originally given the opposite and adjacent to this angle, so we are going to use tangent of theta to determine that angle. Okay, so tan theta, with this being theta right there, tan theta is equal to 21.915 divided by 50.945. Okay, when you divide those two together, you're going to get 0.50869, but I want to get theta by itself. So what I'm going to do is take the inverse tangent of both sides. Let's keep going up. So theta is equal to the inverse tangent of 0.50869. When you do that, you're going to get your theta is approximately 26.96 degrees. Now we want to express this to 3 sig figs. Again, remember the original problem gave us certainty to 3 significant figures, so we can round this. This 6 is going to round the 9 up, which is going to round this up to a 27. So you have to express your theta as 27.0 degrees. So there's our theta. We have our speed from before as the 57. That's what we found. So we can express our final velocity. Therefore, the velocity is 57.2 meters per second, and then in square brackets, 27.0 degrees, let me shift that up, above the horizontal. Wow, and there you have it. We are at 19.5 minutes. Hey guys, that's it for the video. Please be sure to give that like button a click if you found this video helpful, and share it with your friends on social media, Facebook or Twitter, if you think they can benefit from this as well. Overall, please subscribe to my channel so that you can catch new videos. I post every weekday at 12 noon, so be sure to check out my channel at that time. Thanks guys, and I will talk to you later.